Ну что ж, начинаем нашу сессию.
So we can start our session, and our next presenter is Anataly Anfinogenov. He will speak about migration to PostgreSQL from Oracle. Hello, my name is Anataly Anfinogenov. I represent Research Institute of Railway Transport. We are the main research department of Russian Railways Company. Our institute employs more than 1,000 people. They solve various tasks. They try new equipment, rails and trains, and we also develop technological software that allows our mother company to settle specific tasks. I am Deputy Director of Research Center responsible for transfer modeling and energy use optimization, and I am also the head of software development department. Our mother company uses several softwares that were developed by us. This is technological software, so it should be very reliable. It should work for a long time. It should be possible to improve it, and it should work 24/7. Now, there are servers installed in all railway centers. There are 16 of them actually in this country, and the system is high-tech, so it is a distributed system. Every railway has a group of servers that interacts with its neighbors. We regularly update our system. The technology of railway transportation is continuously improving, so it should be represented in the software that makes it possible for us to do it. Apart from this system, there is also a system that makes it possible for us to optimize train flow. And, it is a bit similar to the previous presentation. We use three-chain architecture. We have heavy clients. They work on C++. We have web clients. And all of this interacts through enterprise messaging. Those are NQ servers. We have open patches located on Windows, on Linux platform, and we also have a server of this application. This is a free software written on Java, and the basis of it is database written on Oracle 11. The edition is standard edition 1, and all interaction with the database was through the layer of stored procedures. Yesterday and today we heard several presentations devoted to stored procedures. I would like to develop on this issue. I agree with previous speakers that we should talk to the database through the layer of stored procedures. Why did we select stored procedures? They separate the logic of storage that can be quite complicated if the application is complicated from the business logic of the application as a whole. So the base doesn't need to address web server, and the web server shouldn't know where the primary keys are stored, and it should address the base through these procedures. In that case, the things that go on inside the base can be changed irrespectively of the things that go on the upper level. So it's possible to modify the database without changing the application. So even if the number of columns of primary key is changed, you understand that in one case it will be really terrible, but if it is inside one procedure and you should change only one parameter, it will be much easier. And the use of stored procedures makes it possible for us to diagnose, monitor and debug applications, so that if you have an application you cannot stop it, you ask it to repeat it, and something unclear goes on, you can deal with it if you interacted with it through a stored procedure. So in your log you can see that this procedure was called at this time with this set of parameters, and after that we use test environment, and using debugger or without debugger we can understand what happened. If this query was generated in different places, it will be very difficult for you to restore the situation and understand the reason of the problem. These are the source data, and these are the data that we had by the beginning of the previous year. Our standard was edition 1. Everyone was using enterprise, but I decided to use 1. But it actually costs much cheaper. So why do we need to spend more money if the tasks of the customer do not require using more advanced options? This is one schema about 250 tables and 50 gigabyte data for one railway application fulfills large transactions. One entity can have 1 million objects of one nature and several thousands of objects of another nature, and all this information should be presented in various tables. And we also get information from many foreign systems that are connected to our system because we are connected to the general information space from our company, and we receive information from this company. These are brief transactions. So we have double profile of load, but the main profile of load includes large transactions. Over 10 years of our system development, we have accumulated more than 200 stored procedures. And Oracle Edition was the cheapest one. It did not include standby, but backup is obligatory in these tasks, so backup was done by application. So the main and backup server synchronized these chunks of information. These chunks were received rarely, and that was alright for us. So these large chunks were copied and protected by the application, and small transactions could be easily recovered. So we used autonomous, independent transactions to write logs. Why? Imagine that you code a procedure that takes 5 minutes, it operates millions objects, and something went wrong, so it crashed. If you use independent transaction, isolated transaction, then the logs will be saved in the base. Because in Oracle, actually, independent transaction doesn't depend on the main transaction. We will be able to recover and debug this situation. The use of temporary tables when I receive 1 million objects of one type and 500,000 of objects of other types. Of course, I cannot work through command line only. The server of the application fills in temporary table with it. After that, it calls the procedure. I address the temporary table and I can do what I need to do. And when I returned all of that, I open it, I open cursor, and I can read what I want to return. Of course, this is another layer. It actually separates storage layer from the logic of application. And we often used merge operator for saving data. But suddenly, our mother company told us to be engaged in import substitution. That is about saving money and increasing reliability. So they said that we had 1 year to transfer our system to Postgres. And why did we select Postgres? Postgres is DBMS that is closer to Oracle. It's possible to write stored procedures. The language is very close to it, and Postgres team is highly professional. There is database, and everything was translated into Russian. So it was our only option actually. And what did we need to do? Well, we were to change the engine so that no one would notice that while the car is still riding. So we wanted our users not to notice this substitute. They gave us 1 year. Our developers team is quite small, up to 15 active developers. And actually, my colleague and I were responsible for the base. My colleague used to work in the main computation center. He had worked there for 30 years, and another developer was the main architect of application server, because the application server was on Java and still we needed some modifications there. It was different, and he also had things to do. So we decided that while we use both the bases, the interface was to be similar for Oracle and Postgres, so that changing configuration and restarting our system, it would be possible to switch from Oracle to Postgres and vice versa, because we didn't actually know how Postgres would behave in the beginning of the process. The admins that were using Oracle didn't have experience of working with these Postgres, so this was very unclear for us, and that's why we decided to be on the safe side. And we had to select vanilla Postgres, although we really wanted to take professional Postgres. And it's not only related to support service, but it's also related to the functions that are important for development planning, because you can program in different ways. And some issues had already been done in professional Postgres, and you don't need to reinvent the matches, but sometimes we actually had to do that. And last year, actually, and the year before the last year, we were already thinking about that because we received this task, and at that time, one module of the top level was already transferred to Postgres 10.6. Actually, there were 20 tables and 11 procedures there. Most of them were get and save. It's not really difficult, and we didn't manage to make login there because we didn't have time for it, and it was like a training project. We just knew the means of debugging that we needed and the base. But still, it allowed us to get experience in administration and setting. And another aspect that was pleasant for us is that in our subject matter, and I'm speaking about railways, we were the first. It means that on the one hand, it was difficult for us, but on the other hand, it was possible for us to do it in the way that is most appropriate for us. So we started doing that. But to do that, you need to plan your actions, because we are actually inbuilt into enterprise. So there are a lot of issues that do not appear during commercial development. So the first thing was to build general migration technology, what we were going to do during the year. The second issue that is very important is self-education, because Oracle and Postgres are similar, but they're not completely similar. The third issue is to develop instruments, some infrastructure solutions, and circumventing ways for us to use something that was not present in vanilla Postgres in the very beginning, but something that we really needed. After that, it will be necessary for us to transfer the description of tables, think about data transfer, the things that we will do with views, sequences, and others. The most interesting part is the transfer of 60,000 strings of code to PGSQL. After that, we were to fulfill testing, debugging, optimization, experimental use, and so on. And after that, it's necessary to develop switch technology. When your software is ready, you have some data left. What can you do about them? So what is the order of your actions so that your user wouldn't suffer? After that, we are in enterprise. It means that there is a long list related to the documentation, so that the system built in mother company would maintain it and act in a specific way in case of a crash. So there are a lot of documents regarding this issue. After that, it's necessary to train administrators. So the administrators that service our system in all railways are actually deeply engaged in this work. We know them really well. They have always worked on Oracle, and apart from our system, they maintain other systems as well. They have a lot of work, they're busy, and of course we cannot expect that each of them will studying Postgres by themselves. That's why our task was to train them so that they would be able to take the system from us for maintenance, so the things they should do in various cases. After that, organize the maintenance, get embedded into the system of queries, and ticket enclosure, how to do updates, because of course when we are in that process we start providing updates not only for Oracle but also for Postgres. And in gray, actually we marked documents full, and it's not actually interesting for everyone. So we get ready for the work. The first thing is to create general technology of migration. Postgres is free. It contains everything, and it was so good for us. It turned out that we had everything we needed because standby works here, and even if I want to make definition of objects, I do not need to use the second base because replications come to standby automatically. As I said, we used vanilla edition, and we were to talk to the customer of the company regarding the way we would do that. It means that we select a specific action plan to exclude some disadvantages. After that, we should order the computation resources and devise procedure for data transfer. And after that, self-education starts. So first of all, we need to understand that this is a different DBMS. This is similar to Oracle, but still it's not Oracle. And it is, PGSQL is not PSQL. So it is different. We learn about extensions. Oracle didn't have the notion of extensions, and in this case, the use of extensions made it possible for us to settle many difficult problems we wouldn't have coped without them, and we select the tool that we use every day when working with the database. We used SQL Manager, although we use Linux and it's actually on Windows, but still it made it possible for us to use a debugger, and it was important for us to have a debugger. After we accumulated experience, we didn't need it that much. So what about the infrastructure solutions that we really needed? First of all, we needed isolated transactions, because in our application, an opportunity to write logs and after that understand what goes on inside the application was very important. Vanilla Postgres does not maintain isolated transactions. Emulation of isolated transactions that is recommended in the community is to use dblink, but using dblink all the time is bad. It is too expensive. So creating join or asking something, a function that takes microsecond, after that we close it and do the same thing after some time, and that is really bad. So I would like to thank Ivan Frolkov for creating the extension PG variables. We use it together with dblink and managed to solve this problem. So you open database link and memorize its PG variable, and all other calls, if it works, you can actually use that to have your log passed through it. And you can also use the base where you are working right now. Actually, for our convenience, we write in the same place, but you can write logs on a different server. Another important issue, log logging should be permitted, so you shouldn't launch database application just to change the set of information that get into the log. All of that should be in a specific table. When you introduce modifications in the config table, you can change information that gets into the log, and you can switch off logging if you are not satisfied with performance. Another issue, we needed temporary tables because accepting 1 million objects through procedure parameters is not possible. Accepting them in the common table is bad because these persons will get into wall, and this is temporary data. They are needed only in the time of call, and if transaction fails, we do not need this data at all. We need this data only when the procedure is called. Oracle had temporary tables that are known to our data vocabulary, and information was erased in case of commit, but they live from one session to another. In Postgres, temporary tables do not outlive the end of the session. For emulation of temporary tables, we used unlocked tables. They do not get into log. It lifts the issue of performance, but some other problems appear. This is not the best solution actually, and we amended it. And of course, we should specify specific ID layers, and data inside this layer for this transaction are unique. But these GUI should be formed and cleared somehow. And also we need to take into account the problem of performance. Oracle used package tasks. These are jobs, because we needed to launch the tasks of internal monitoring, clear outdated data, collect statistics, clear something, make some checks. So we continuously had 4 jobs. And in this case, there were no internal resources for jobs. We wrote a separate Java application. It can be launched on this machine or on a neighboring machine. It launches a set of procedures or other operators. And the set of jobs is emulated. So in Postgres, someone should say commit from the outside. I think that making commit from inside, actually this opportunity appeared only in 2011.
So we use database link to ensure logging Postgres PDV, to interact with adjacent servers for technology purposes, also to generate GUID, to deal with indices, to rebuild them without stopping the database. Our database should be ongoing, PG variables for logging, and Oracle FDV to create database link towards Oracle server. Oracle can create a link towards Postgres, at least for free, and no one will give us money for the Golden Gate. The drawback of those solutions is that they make update of database more difficult because it is all tied to the version of libraries on which it was collected, and it is impossible to update the system because you will get a lot of issues. You either test it heavily or freeze the mechanical update of the version. Item 4, transition of tables in views and sequences. The main question is to compare types of data, and mechanics doesn't work here. If I had a table with integer field and I stored something in it, as a developer I need to say which type it should go to in Postgres, and depending on the context, it can be small int or numeric, and all the overhead will be different. Types in Postgres are richer than in Oracle, so you need to just sit down and think about it, to think how it's going to be displayed on each other. We do not have blobs, thanks God. This made it easier for us in transition, but we'd have slobs for big objects. They transition to text, they fit into it. We also have row objects to store unstructured binary data. We also used row ID. It transitioned to byte. The primary key was made of 6 components. When bad strings were filtered, it was necessary to remember ID of those strings and then delete them. Without knowing that WID became deprecated and version 12 does not 12, we will have to further develop a unique key for those tables. I learned about it when I came to Krasnoyarsk in November last year. So we have prepared soil for planting things. Now about the text of procedures. What to do with the merge operator? Merge was used as the insert operator. If it is present, do insert. If it is not present, do update. In Postgres, this structure turns into insert and conflicts to update or do nothing depending on what's going on, and it works better. Last year at this conference I asked, when will you do merge? And today I'm not even thinking, why would I need merge? I will not use merge any longer. Second thing is packages. Procedures were not all by themselves, they were in packages. It structures code by tasks. The package dealing with administration of the database and deleting obsolete data should not be linked to the package dealing with the main functions and interacting with the server applications. They're not overlapping at all. There are no packages here, each function is by itself, so not to keep them in a big pile. The application server is used to use certain prefix before calling those procedures. We created a schema with the name coinciding with the name of the package. This is a traditional approach. When we started using extensions, we saw that this approach was very sound, because objects are thrown into the public, and if we don't care about deleting our objects or placing extensions appropriately, it will be a complete mess. We will not be able to differentiate incoming and outgoing functions. So do not create your own functions in the public, if possible. There was one more thing which we really liked. DDL operator does not automatically cause commit. If in Oracle you do alter table, you will have commit. If you start transitioning the database from one state to another as a result of update, when the first commit happens, you cannot reverse the process. Here you can finalize with the only commit or reverse at any stage necessary. This is really great, but at first it was quite confusing because you see the system doing something that you didn't command it to because it didn't apply commit. Postgres functions may have the same name but a different set of arguments as in any developed programming language like C++. This is probably good, but in practical life it stands in the way in development. As long as some type grows into int, you may have two functions with a huge number of parameters which are different by only one small thing. The application server, it doesn't care whether it's int or big int, it takes it as an integer, so it calls one function or another, and this causes so many surprises and unusual events. As soon as we saw it, we decided to kill all those functions with the same name before it is created in the database, because we wanted to avoid such instances. If you can do it with constraint in Postgres, it would be a great thing. So the more mechanical protections, the better. But people try to fix it in different ways and then forget how they did it. Exceptions. In Oracle, processing of exceptions is very special. Business logic is distorted. It has to do with application. For instance, the train should not arrive to a given location because the routes are not intersecting. So in this case, rise exception is thrown. Exception has a name, it is accounted in the logs. Here we can organize exceptions. You don't need to describe them, but you can use the error code, a 5-digit text field. If you select an appropriate prefix, you can build your own system of exception and control it. Be careful with common table expressions, TTE. If in Oracle we know that this is a pseudo view and you can work with it, it's quite comfortable. In Postgres, it is not the case. Up to version 12, it materializes with certain costs. In version 12, you can already control it. So this is the diamond, my collection of issues, empty strings of null. Oracle believes that null and an empty string are the same thing. Therefore, if we take an empty string with a null string, this string is saved. In Postgres, null and empty string are two different things. If it says if something is null, then do this, and with the client I got an empty string in the form of an empty string, then the system stops working. Although in the log you can see something empty, but it is not empty in reality. This caused us a lot of difficult moments. And an empty string and nulls information in the log. So basically this null turned out into emptiness, so we had to fix that too. So there are two of us and there are a lot of stored procedures. We have created an infrastructure, we learned how to write logs, how to control performance, so it's time to do real things and migrate the procedures. If we do that by hand, we'll never be able to accomplish it. So the rescue was over at 2PG. I think it is in version 12. This is a set of scripts which helps convert Oracle installation schemes, objects, stored procedures, values into a set of scripts or Postgres database. We didn't care about the database. We took the current installation and get a number of directories, table directory, packages, use directory, etc., where, according to the conversion rules, the system has converted the description of all objects. Yesterday, Paulos spoke about the dangers of using OR to PG mechanically. For instance, if you have big int in the table description and numeric as a stored procedure, then you compare the two. Then you select the more serious type, performance goes down, and query is really bad. But keep an eye on the query, on the types, because type conversion, even if it is automatic, do not leave it alone. Please trace it as you translate from old to new. You have to remember this. Number two, always use a definition through the type of a column in the table. We did that in Oracle and decided to do the same in Postgres. PG with is something with GUID tables and an appropriate field. Then it will save you from a lot of issues. So how did we use OR to PG? Because our objects are complex, the business logic of storing is also complex. There are a lot of ifs. How this should be recorded, assembled, if you have a system of ifs. So OR to PG will transition those ifs from one system to the other. So 90% can be transitioned in a good shape, sometimes 50%, but you should work on it. Remember about merge. Merge should be converted to insert by hand. In Oracle, I had everything with alias, both for updates and delete operators. Name of the table, letter, set, letter dot field. Postgres does not understand this. When during compilation in Postgres, you see this when the control got to the procedure itself. So the procedure will create itself, but it doesn't say, I don't know, those updates. It will say you don't have this field in the update, and it will say it's an alias. But the good news is, if by that time you have the logging system, even self-made, so all of this will be recorded in the log up to the string and the operator. So go there, remove alias from the update. It's kind of irritating, but it can be done. The same for delete. NVL2 in Oracle, when in case of null, you return one value, and if not null, another value. So a third argument pops up somewhere in the body, and this was really confusing in the beginning. So you get used to normal conversion, and then sometimes at some point of time you see this. And comment processing is not always trivial. There are some comments or pieces of code commented. So the text of comments may change, but this is not a very serious thing. So we have done everything. The functions are called, objects are read and not lost. And now we start the implementation. Put it on the production server. So we arrived in the evening, launched it, went back to the hotel, came to the office in the morning, and what did we see? If the biggest table was kept on the Oracle machine for 10 minutes, it's a huge table, by the way. So in Postgres, it was stored for 19 hours. So that was really surprising, both for us and for our customers, because 19 hours is quite a lot. Well, everything was kept there for 19 hours, and now it was the time for optimization. To optimize, we need to have the measurement outcomes. Here we needed logins and time of execution of certain procedures. So it all started with the measurements. This is what it looked like. In our application, these values, this is one SQL operator or a group of SQL operator logically related within one procedure. And the procedure was made of so many units, insert, update, delete, or group of such operators. So for each heavy operation, the log indicated the time of execution. This is the new version, this is the old version, this is the iteration time in milliseconds. So it is in milliseconds how long the new operation took place. But we had quite a discovery at this point. Let's take some phase, pre-sorting or creation of copies. Suddenly, it takes 99% of time. What happens? But this mechanism helps understand what the problem is and fix it, because when you launch a procedure and wait for 19 hours, you can't really understand what's going on. It slows down the development process. But when you launch this time diagram, you can easily understand what's wrong and fix the problem. So what were the problems and how we fixed them? 6 hours from the start of this 19-hour procedure, we understood that unlocks in the tables worked very slow. Recording was fast, reading was fast. But if we use them as we used to do in the temporary tables, for instance, if we want to do update or delete in the table, cut data, improve data, change one ID for another, it gets really slow. There are no keys. In Oracle, they were all by itself. Indices were not necessary because they used 100% of data, and no index will work with 100% of data. What helped us is creating a CTE. So CTE helps us raise a certain layer. The amount of data goes down. So the time went from 19 to 6 hours, which was still not enough. Let us not use logs then. The application server should not say create table. It dumps its logs into its layer, this heavy load. Then inside the procedure, I say create temporary table in the Postgres style. Then I do insert, create temporary table as in select. It gets into TMP input, millions of strings. So the procedure became 600 times faster. This has become a truly temporary table. Everything was fast except for the overheads incurred. Very charming. Instead of 19 hours, it got to 15 minutes. So what else could we do? We saw then that this magic word analyze this temporary table was really magic, and we were able to cut the time another 2.53 times. So the Postgres planner has no time, no idea about what is in the table. Analyze table is really fast. It is less than 1%, even for very heavy tables. But further acceleration is magical. Was fantastic. It was faster than in Oracle. For example, let's take one procedure which did save. The save procedure was really quick. What other performance reserves did we see? Quite unexpected ones, very specific for Postgres. Update and delete also lead to better performance. For instance, if you replace ID in a table to some new IDs from the temporary table, we can do var exist or variable subselect, or you can use syntaxes from, which is specific for Postgres. The syntaxes, which is specific for Postgres, is much faster. Same for delete operator with predicate var exist is slower than delete with using predicate. There may be a scientific explanation for it. I'm only sharing my practical observations. So thanks God, adjustment setting, we did this, and now we're getting ready for the transition or for the switching technology. Some people spoke about how hot data from one database could be taken to another database. In our case, it was good because the users transitioned the database. They basically saved themselves into a new database. In Oracle, we had two servers linking through application means. So the procedure of retrieving schedules from the main database to Postgres, they connected through PDV to Oracle and worked perfectly well. So the schedule was taken from Oracle and put into Postgres through save and other procedures which I mentioned.
So 99% of data were naturally moved to the new base. The bases were synchronous, so the servers of two different manufacturers worked as a synchronous pair. So, until the switch, the leading server was Oracle server and the slave was Postgres server, and after the switch, their roles changed. And for the transition period, we agreed that Oracle would be preserved so that if something fails, Railway wouldn't suffer. And we hadn't actually needed to do that. This system has worked since October. And in summer, Oracle will be switched off. The next stage is to develop the use documents so that people would be able to install Postgres and extensions, to use our application, to check the logs and to understand if something is wrong. So, the use of stored procedure makes it possible for us to implement proactive monitoring system in the base. The application should select a set of key indicators that show its state. And there are some requirements of external monitoring, as in any enterprise. So, the system gets data, that is one thing, but there is also internal monitoring. We're developers, and we are the ones that know best what shows the state of the system. And this approach is really convenient because, some indicator can take a lot of time for being calculated. You cannot call it too often. And if it worked out a table, you can send external monitoring system there, and using select, it will state whether it is good or bad. This is a stored procedure as well. And apart from menus, it was also necessary to train people. So I would like to thank Postgres Pro using this opportunity because they make a lot of efforts in organizing these conferences. We understand that. We train our admins as well. Once a year they come to us, and I understand it's really difficult to arrange this conference so that everyone would be interested in it. And we also have remote training. And now I'm coming to the end of my presentation. So it started working in the enterprise. We received back reports and queries for the implementation of new functions. So frequently updates are issued, and we are third-party developers. We are daughter company, so we prepare documents. Documents are coordinated and approved, and after that they go to the administrators of Russian railways. They assign logs and specify everything. And in case of Oracle update, if something went wrong, and it happened actually because we're all humans, we can make mistakes. So what can we do in that case? If it just failed in one table, it's necessary to recover the base in that case. It was a major problem in Oracle, but in Postgres, until final commit, nothing happens. So it makes our life much easier. Well, we have drawbacks in terms of vanilla version because we are closely linked to this version. We assembled it there, we compiled it there, and we cannot just update it. We cannot say you update. We should recompile it, reinstall it, or wait till we move from version 11 to version 12, or we can use Postgres Pro. As I understand, PG variables are integrated there, and probably in that case, it will be updated within one unified update system. And the last stage is to make final improvements and provide it to the customer. So, this system has worked since October on one road, and in other roads, Oracle is master and Postgres is slave, and we're doing that actually to delay this process a little bit, because after the usage was started, indices started to load, and understand that we need to have some typical cases and understand how to react to these typical cases. And we plan this process to finish in other railways by the summer. Well, we actually were able to do that earlier, but we couldn't do it because of New Year holidays. So let's summarize the results. Migration was successful. Further issues include maintenance. So the way this base behaves during its usage. Our indices are transformed to input, export, backup, the organization of version update. And PG store is in a different place in version 12. And finally, our customer gets real benefit of import substitution, because even Oracle Standard Edition 1 actually cost $6,000 for one processor. After that, they killed it, and instead of one, they made two, and it actually cost $15,000. But this is Standard Edition 1. But if you want to use Enterprise, you should multiply it by the number of kernels, and the price will be much more expensive. And in this case, we can save dozens of millions of rubles. Well, but probably we shouldn't use the vanilla version. I think that actually it's worth the pain. Normal base support worth the pain. But that's not enough. What is not enough for us in terms of Postgres? What would you like to have? For example, the log of strings with specified timeout. The problem of simultaneous access arrangement looks as follows. Our developers sit at their workstations. One person prepared a schedule, and their colleague could actually modify it a little bit, or this person started saving it from this working station, and it seemed to this person that it takes too much time. In that case, this person comes to a different workplace and starts saving once again, and these operations are in a queue, so it's not possible to save them in parallel. They are saved consecutively, and the queue is created due to select from update. And in Oracle, I can specify timeout. In that case, the queue would be destroyed by itself. In this case, I can say select from update, no wait, or I can wait endlessly. I don't know if you know what is burst. There are some circumventing solutions, but actually this timer would be useful for us. Another issue is the rigidity related to specifying types and parameters of stored procedures. So we even have to use varchar. And it would be good to write the plan of implementation at the moment of implementation. So if I log plan apart from implementation of this procedure, I can understand what went wrong. So if some procedure increased, for example, the plan has changed, and I made a full scan to this index, in that case, I can take this decision very fast. But in Postgres, there is no embedded mechanism to influence the plan when I am inside the procedure. So I follow 30 points, and at point 24, there is a heavy save, and I would like to record it, but I cannot actually do that, unfortunately. Limited functions of isolated transactions for writing logs, and pgdump. This is a very good utility, and it would be even better if it was improved. An opportunity to specify parameters not from the command file line but from the file, when there are some tables that should be extracted from export, and there can be hundreds of them, and command line looks quite weird, and specifying additional filters. It's possible to filter only the names of tables, but it's not possible to filter the data. And actually, it would make it possible for us to upload 1% of data, for example. And some tables would be uploaded empty, others would be uploaded with data. It would be very flexible, and there is one filter there, so it's possible to add another one, and an opportunity to sort objects in case of uploading. So if the objects are sorted, if we have two dumps, we can compare them automatically, and we can compare the databases. And now the procedure of pgdump uploading is random. We cannot compare these databases. Thank you. Thanks a lot, Anatoly, for your presentation. Unfortunately, we have no time for questions, so you can ask the questions personally during the break.